In 1999, scientists stumbled upon a hidden cosmic gem some 40 light-years away from us, TRAPPIST-1, a red dwarf star. Little did they know how lucky they were. 17 years later, our telescopes revealed the star's first planets. And the very next year, we uncovered 4 more planets orbiting the M-type star. Today, TRAPPIST-1 is the most studied planetary system aside from our own. Its 7 worlds are all rocky, strikingly similar in mass and size to our home planet, and some possibly containing more water than the Earth's oceans. For a very long time, scientists struggled to study distant worlds. But a lot has changed since the James Webb Space Telescope came into operation. So how habitable is the TRAPPIST-1 system? And what would it be like to live on one of its worlds? Let's find out this and more. The James Webb Space Telescope was built to study the early universe, back when the first galaxies and stars were forming. But what makes it really special is its ability to analyze atmospheres around distant exoplanets. The telescope's near-infrared spectrograph and a mid-infrared instrument are able to measure a different spectrum of light emitted by faraway celestial bodies. This helps scientists identify the composition and temperatures of planets and their atmospheres. And on top of that, JWST has a powerful infrared camera that can see through an exoplanet's thick cloud cover and help us study its geology. The problem is, TRAPPIST-1 is an M-type red dwarf, which are the most prevalent in our galaxy, and the most active stars we know of, emitting powerful flares several times a day. And since studying an exoplanet's atmosphere takes observing light as it passes through it, it's difficult for scientists to distinguish ordinary light from the stellar radiation caused by the flares. But the James Webb Space Telescope is much more powerful than any other telescope known to science. Its precision in detecting brightness fluctuations is comparable to looking at 10,000 light bulbs and seeing 4 of them being turned off. So what has the telescope discovered about the TRAPPIST-1 system so far? Recent observations showed that the closest planet to the star in the TRAPPIST-1 system either has a very thin atmosphere, or none at all, and it's most likely a bare rock. This innermost planet called TRAPPIST-1b is a scorching hot, rocky world. With a blistering surface temperature of 450 degrees Fahrenheit, 230 degrees Celsius, the planet is too close to its parent star, much like Mercury in our solar system, which places it outside of the habitable zone. Slightly farther out, another planet rotates around the red dwarf, TRAPPIST-1c. In the past, it was believed that the second planet in the TRAPPIST-1 system was similar to Venus, but the data from James Webb Telescope proved scientists wrong. The planet doesn't have a Venus-like thick atmosphere. And while the temperatures on the day side of this world are still extremely hot, about 225 degrees Fahrenheit, 107 degrees Celsius, it is now considered the coldest rocky planet ever studied using this new method. In such harsh conditions, water would have evaporated long ago, even if it was initially present on these worlds. But according to a new study, the rest of the planetary system might have stayed cold enough for water to remain there, either in a liquid or frozen form. The lightest of the planets in this system, TRAPPIST-1d, has around 30% the mass of the Earth, and a radius of approximately 80% of our planet. Because of such small mass, the planet probably doesn't have a dense atmosphere, or an abundance of heavy elements. But it still bears similarities with Earth, such as the amount of solar radiation it gets from its star. Located just on the inner edge of the habitable zone, the planet's temperature without an atmosphere would be about 48 degrees Fahrenheit, 9 degrees Celsius. To compare, if there were no greenhouse effect on Earth, the surface temperature would be freezing, about 0 degrees Fahrenheit, 17.5 degrees C. But what's exciting about this world is that it could harbor a staggering 250 times more water than our own planet. although the planet's potential habitability remains uncertain. But there's one factor that might change this. It's known as albedo, which is a measure of the reflectivity of a surface, typically expressed as a percentage. It quantifies how much incoming solar radiation is reflected back into space by a surface, rather than being absorbed. In other words, it describes the ability of an object or surface to reflect sunlight. Albedo values range from 0 to 1, with 0 indicating that all incoming radiation is absorbed by a perfectly black surface, and 1 indicating that all incoming radiation is reflected by a perfectly white surface. The Earth's average albedo is 0.3, and so if TRAPPIST-1d has the same or similar value, it could provide an environment suitable for some forms of life. This is because water vapor acts as a greenhouse gas, but with the Earth-like albedo, the planet would escape the runaway greenhouse state. Scientists think TRAPPIST-1d is covered by a global ocean. But for life to thrive there, it needs a tidal heat flux 20 times stronger than what Earth has. Tidal heat flux is like a special kind of energy generated by the gravitational interactions with nearby celestial objects. On TRAPPIST-1d, this energy would act like geothermal heat that could sustain chemical reactions in its gigantic ocean. Some forms of life derive energy from chemosynthesis rather than photosynthesis even here on Earth. So there's a possibility that TRAPPIST-1d could be a unique home for life that doesn't rely on sunlight. And if the planet has a thin atmosphere, its twilight zone, or the border between the night and day sides, could be habitable as well. Among the planets in the TRAPPIST-1 system, the fourth one, TRAPPIST-1e, is the most promising. It's both dense and possibly quite rocky, sharing similarities with our home planet, even in composition. Located in the habitable zone of its parent star, TRAPPIST-1e could hold a thick oxygen-rich atmosphere. And all the hydrogen could have escaped its atmosphere because of how light it is, which is good news since it's a greenhouse gas. If TRAPPIST-1e began with more water than Earth and Mars, and retained it on the surface over time, its climate could be strikingly similar to what we enjoy on our own planet. That being said, TRAPPIST-1e is considered one of the most Earth-like planets ever discovered. Imagine living in a world where a year lasts about 7 Earth days, and the concept of day and night is something completely different from what we're used to. Because of the close proximity to their star, all the 7 planets in the system are tidally locked, with one side always facing their parent star. During a never-ending sunset or sunrise, the sky would be a reddish hue, and you would be able to see the 6 planets in the sky as if they were moons, with some appearing larger than the Earth's moon in the sky. On its day side, the planet might even have lands where humans could thrive. The climate would be much different. Thick storm clouds covering large areas, massive dust storms distributing heat across the planet, and maintaining a temperature balance necessary for complex ecosystems to flourish, while also generating powerful winds, tornadoes, and hurricanes. The night side would be a harsh place, even for expeditions. This is the realm of Arctic cold and towering glaciers that dominate the landscape. Although a constant twilight might get a bit tiresome, it offers a crucial advantage, especially for the first settlers. In the distant past, our ancestors used the ever-shifting constellations as direction guides. But on TRAPPIST-1e, the nearby star is always at a fixed position in the sky, so it would be like having a permanent North Star to show you the way through the uncharted territories of this alien terrain, although it would appear several times larger than the Sun. In our galaxy, there are 10 times more of these M-type red dwarf stars than stars like our Sun. These little red dwarfs hold promise as potential cradles for life, with trillions of years for life to evolve and flourish in their cosmic neighborhoods. However, as we've mentioned earlier, even though they're normally dim, many red dwarfs can suddenly and dramatically increase their brightness. This supercharged mode is like a star shooting out solar flares on steroids. Some scientists think that the flares from the TRAPPIST-1 star might actually be helpful for life on the nearby planets. These flares give off a lot of energy, and that energy could have kick-started the creation of important molecules like amino acids, which are building blocks for life. So, while the high-energy radiation from flares could be harmful and maybe even sterilize a planet's surface or strip away its atmosphere, it could also provide the extra energy needed for early forms of life to develop. Although data shows TRAPPIST-1 is a much safer host star, its flares are about 30 times milder than those seen in other red dwarfs. But since the 7 planets in the TRAPPIST-1 system are tightly packed, the effects would be noticeable. And this means that auroras on TRAPPIST-1e would be nothing like the ones we know. Human bodies are fragile, so even weaker but frequent solar flares from the star pose a constant danger. Here, auroras act as natural alarms, signaling the incoming flare. To survive, inhabitants would rely on an exponentially stronger magnetic field or be prepared to seek shelter from the impending radiation in underwater cities or underground bunkers. So what do you think? Would you leave Earth for the new home? Or wait until we find an Earth 2.0? Let me know down in the comments. And don't forget to like this video, share it with your friends, and click the bell to stay updated on the latest space news.